Recall from the unit on tangent planes to a surface that the equation of a tangent plane to the surface z equals f of xy at the point x sub 0, y sub 0, z sub 0 is given by z minus z sub 0 equals the partial of f with respect to x evaluated at x sub 0, y sub 0 times x minus x sub 0 plus the partial of f with respect to y evaluated at x sub 0, y sub 0 times y minus y sub 0. Instead of the x-axis, we're going to have a v-axis for wind speed. Instead of a y-axis, we're going to have a t-axis for time or duration that the wind has been blowing at that speed. And instead of a z-axis, we're going to have an h-axis for wave height. So we're going to recast our equation for a tangent plane in terms of v, t, and h instead of x, y, and z. So we'll start by rewriting our formula for a tangent plane in terms of v for wind speed, t for duration of wind speed, and h for wave height. So we're going to have partials with respect to v and t instead of partials with respect to x and y. Our point v sub 0 is going to be 40 knots, t sub 0 is going to be 20 hours, and h, the corresponding wave height in the table, is 28 feet. We're going to estimate the partial with respect to v at 40, 20 by averaging together two pairs of points where we are holding the time t constant and looking at change in wave height over change in wind speed. That's happening either side of 28. And when we do that, we get 23/20 as our estimate of the partial with respect to v at that point. Doing the similar thing, getting a partial of with respect to t, we're going to hold the wind speed constant at 40 knots and then look at points either side of 28 and get change in height over change in duration, and then get the average. And when we calculate that average, we're going to wind up with 9/20. Now we're in a position to get a tangent plane equation to approximate f of v of t near our point of tangency. We're going to move h sub 0, or 28, over to the right hand side by adding 28 to both sides. Then our value for f sub v is 23/20 times v minus 40, and our value for f sub t is 9/20 times t minus 20. So there's our general equation for linear approximations. To find an approximation of wave height when the wind speed is 43 knots and it's been blowing for 24 hours, we plug in 43 for v and 24 for t, which we're doing now, and do our calculations, and we get 33.25 feet